Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 12th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean, and of course, a look at potential for snow in the Sierra and the Pacific Northwest. Let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see a small area of seas 22 feet off of Vancouver Island, not doing a whole lot. This part of a system previously that was just in the eastern Gulf that generated swell pushing into Northern California on Saturday evening, produced raw, windy swell into Sunday, and that swell is working its way down the U.S. West Coast, probably into Baja by now. Also, cut off low north of Hawaii, generating 18-foot seas, but aimed away from the Hawaiian Islands. And other than that, a pretty quiet pattern is in play. Let's take a look at what's to come. First up, we take a look at jet stream level winds. These winds of about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, that is a dip in the jet that goes to the south, and we really don't see anything like that. Now, there's a good batch of winds pushing off Japan, 190 knots. That's pretty strong, almost pushing 200 knots. But notice that the jet, this is right here, the jet splits even west of the dateline, and the northern branch goes up over the Aleutian Islands, hugging the Alaskan coast, down the Pacific Northwest and inland. And so there's no trough, there's no place for, support for gale development. What you want is a dip in the jet that helps create a counterclockwise flow, and there's almost like one trying to organize there. That counterclockwise flow aloft also manifests itself down on the surface, and of course, counterclockwise rotating winds on the ocean surface in the northern hemisphere is the sign of low pressure. Low pressure, if it's deep enough and strong enough, generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, turns into surf. So right now, there's nothing that we can see in the northern branch. In the southern branch, well, it doesn't do anything really for producing surf anyway. But when you have this split flow between the two split flows, all you typically get is high pressure, and that's exactly what's going on, causing just this steady flow of north winds down the Pacific Northwest and California coast. I mean, it's just been a wind machine. It doesn't stop. There hasn't hardly been any glassy days. If there is any glass, it's there for an hour or two, and then it's gone. So just that's been the way the season has been. It actually looks, this is kind of typical of like a La Nina year where you get this split pattern, it just holds. But even shorter term, this is a classic sign of the inactive phase of the MJO, and we'll get into that in a little bit. But for now, split jet stream is in control. Put this into motion. We get ourselves into Monday. No real change. Winds back off. See, there's the trough right there, but it's all like over the Kuril Islands, Kamchatka, Russia, not over ocean water. A little bit of a trough tries to organize here off of Canada on Wednesday, sort of what I'd call more of a backdoor trough. It falls south, pushes inland over San Francisco Bay Area on Thursday, and then it's sort of back to the same pattern, but notice, at that time, come Friday, the split completely disappears, and all of a sudden, it's looking like we're having almost a consolidated flow. Yeah, a little bit split here, but things are looking like they're trying to organize. No good troughs. Oh, there's one as of Sunday pushing through the Gulf of Alaska, and there we are at 180 hours out. So things are improving slightly in that the massive split that's currently in play over at least half of the Pacific Ocean is supposed to be gone, but no real defined solid troughs are forecast, and wind energy for the most part is pretty weak across the entirety of the jet. That is not conducive to gale development. All right, that's what the upper level looks like. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. Okay, now remember, the jet was pushing straight off over Japan, splitting out here, doing something like that. And sure enough, look at that, a 1040 millibar high. That's a very strong high pressure system, just fully locking down the entire eastern half of the Pacific. And that pretty much negates any attempts for low pressure or storms of any kind to form. Not good. And it also produces the wind that's been in play down the California coast, but it also, around high pressure, winds circulate clockwise. Around low pressures, counterclockwise. There's sort of low pressure there. Okay, there's low pressure there. There's a counterclockwise flow. But the high pressure is also generating strong trades that have just been pounding the Hawaiian Islands for weeks now. Trades are great and all. They're offshore on the north shore of Oahu and other select breaks. But it also makes a lot of this like east-northeast wind swell, and it creates a bunch of warble. Yeah, it's rideable and you can get waves, but that's not really what you want if you want real surf. All right, so let's put this into motion. Let's see if there's any hope. We get ourselves into Monday. High pressure still holding, if anything, building in coverage. See these little weak low pressure systems trying to push down the coast, but nothing. There's low pressure. It instantly gets shunted off into the Bering Sea by high pressure holding over the eastern half of the Pacific. Now we get into Wednesday. Another one of these little backdoor lows sets up getting into Thursday. Look like it could possibly produce weather for California. So, a little bit of rain will take that into Thursday. And then here we are into Friday, a gale, sort of a complex gale. There's one low right here, 45 knot winds, 35 knot winds Friday, pushing towards California. This looks like it has opportunity. Oh, and remember, the jet is not split at this point. It finally consolidates, pushing the whole way across the Pacific. And lo and behold, this looks like an opportunity for not great surf, but something. 40 knot winds, a pretty broad area, 30 knot winds. So that potential for surf, at least for California, not so much for Hawaii. But then on late Saturday, another low is supposed to start building. Fetch aimed at the Hawaiian Islands. This is 12Z on Sunday. We'll run it right out to 180 hours out. And then, so it's pretty obvious just by looking at this that when the jet is doing the right thing, instantly the gale machine wakes up, and when that happens, then you start getting precipitation if it moves inland to California, and certainly surf across the Pacific Basin. So things are looking a little bit better starting, we'll say 5 or 6 days from now and moving into the future. What is the effect of those winds on the ocean surface? Well, okay, right now we know there isn't a whole lot of wind, so there's not a whole lot of effect to be had. We'll put this into motion. We know there's a little gale that's supposed to set up here off the Pacific Northwest, come into Wednesday or so. Does that do anything? Not really. What is that? Oh, there's a little area, 20-foot seas Wednesday night. A little bit more, mainly a weather producer. But then come Thursday or Friday, the jet starts consolidating. And as soon as it does, there's an area of 22, 24-foot seas and another area behind there of 28-foot seas on the dateline, building to 30 feet. And together, the two of them sort of merge, push across the Pacific. On Saturday, we have, 28-foot seas and one little dot there. Let's say 27-foot seas for the most part. Maybe some sideband energy. Let's pull this back a little bit. Yes, sideband energy could be radiating south towards Hawaii, though the primary focus looks like the U.S. West Coast. But then we know there's another system right behind that. There we go. 27-foot seas, 25-foot seas. We're 180 hours out. Probably some 13, 14-second period swell for Hawaii. Possible, assuming all this is right. I mean, you're looking a week out on the models. Yeah, the models are vastly improved from what they were 5 or 10 years ago, but they're still not great more than 4 days out, something like that. So don't take any of this to the bank. But the good news is it looks like we're starting to move in the right direction. All right, so let's dissect the wind machine. There's our high, 1040 millibar high. Wind circulates clockwise around it. Obviously, we can see the Hawaiian Islands are right in here. You can see 20, 25, almost 30 knot winds, trades. That's pretty strong indeed. That's today. California, yes. Oh, here, we'll make it 0Z, so that's about right now. 15 knot north winds down the California coast to at least Point Conception. Yeah, that's about what it was. It was a pretty ugly, chunky mess today, but there were some waves. All right, get into Monday. More the same for Hawaii, nuking trades, maybe weakening wind pattern along the California coast. New low building up to the north, so we'll say 10-knot northwest winds for the bulk of the coast. We get into Tuesday, same deal for Hawaii, 20-25-knot east winds. California, 10, 15-knot, pretty much the same old drill. And then we get into Wednesday, low pressure sets up. Now, low pressure, of course, counterclockwise flow. You can get that south flow ahead of the low, and there we go. The same deal, south winds, 35 knots up into Cape Mendocino, 20, 25 knots Wednesday afternoon down towards San Francisco. Trades still for the Hawaiian Islands. Get into Thursday, more the same onshore flow, 15 knots for California, starting to weaken later. Trades also back off because why? The high is gone. Low pressure regime starting to set up in the Gulf of Alaska. That's probably good news for everybody. And then we get into Friday, front setting up off of the Cape Mendocino coast, pushing south, but doesn't make it too far. Makes it to about Point Arena. Light wind regime, we'll say from San Francisco southward. Trades, yes, still in effect for Hawaii. 20 knots, but not like what we have been seeing. We get into Saturday. A front dine, it looks like, right over, let's say, Point Reyes. And by Saturday night, light wind regime sets up. 15-knot trades for the Hawaiian Islands. And then light winds finally by Sunday, a week from now, if you believe it, for the California coast. And a reasonably light trade wind regime for the Hawaiian Islands. And there we are, 180 hours out. More low pressures queuing up. Looks like a significant pattern change is imminent starting, we'll say, Thursday of this coming week. All right, a quick look at precipitation for California. We're focusing on California here. High pressure. Here's the low. Inland, yeah, a little bit of rain today for, we'll say, Northern California. There were sprinkles in the Bay Area, but nothing much. Oh, yes, and just flurries, maybe Monday morning for the Tahoe area, but no further south. Another little low tries to move in on Tuesday. Light snow for Tahoe. Rain down to, maybe Monterey Bay, something like that. And then Wednesday, the new stronger low sets up off the coast. This is the beginning of the regime change. Snow, rain, working its way down to Monterey Bay by late Wednesday night. Snow building into Tahoe by Thursday. Pretty strong snow. Rain down into even Southern California, supposedly. Heavy snow for the Sierra, probably short-lived. Rain the whole way down to San Diego. Okay, we'll take it. That's not bad. Then it dries out a little bit as we get into Friday. Rain still for the north. This seems to be the dividing line, somewhere around Point Arena, something like that. North of there, it's been pretty wet. South of there, been pretty dry. Another system comes in Saturday, maybe flurries for Tahoe if you're lucky. Then Sunday, things sort of dry out along the California coast. All right, let's go take a quick look at some at snow. This is accumulated snowfall for the Squaw Valley area, representative of, we'll call, North Lake, Tahoe area. Maybe 10 inches into midweek, and then another stronger dump up to about 26, 28 inches, something like that, and then nothing after that. So total accumulation, we'll call it 27 inches for the next week. Snowfall levels, okay? This is the base of Squaw here. This is the top of Squaw. Anything that's blue is snow. The red is liquid. The gray is sleet. The white is snow. The blue is more enhanced snow. So good snow levels until you get into the middle of the week, let's say Monday or so. Sunday, Monday, Martin Luther King weekend sort of time frame. Then things warm up a bit. For Kirkwood, pretty much the same deal. 2 feet of accumulation over the next week. Snow levels, because Kirkwood's higher snow levels. Freezing all the way to the top, other than this little bit here on the 19th and 20th of January. And, winds, of course. Yeah, pretty windy. Series of storms moving through. Would not be surprising to see 60-knot gusts at the top of the resort there. And then things mellowing out after that come about the 18th or so, 19th of January. And then Mammoth. 9 inches, 10 inches, something like that, all attributable to the storm on Wednesday. So a little bit of fresh snow. Snow level, but because they are so much higher, they really don't have to worry about getting any rain. It'll all be snow. Wind, 60-knot gusts maybe at the worst of it, and then mellowing out pretty much like everywhere else in California. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation and, of course, El Nino or La Nina. All right, so first off, we like to look at winds across the equator in the Pacific, and specifically the Western Pacific in an area we call the Kelvin wave generation area. So this is the East Pacific here. This is the West Pacific here. Here's the equator, the dateline, international dateline, right there. Kelvin wave generation area, 5 degrees north and south of the equator from 170 west. So right here, 5 degrees north and south of the equator. Oh, that's New Guinea there too. So you draw a little box in your mind there, and what we want to see is west anomalies in this area. That happens during the active phase of the MJO if it's strong enough, and if those west anomalies blow long enough and hard enough, they can actually take warm water that's here, push it to the east and in sort of a ball, but not on the surface, underneath the equator. Takes like 3 to 4 months to move the whole way across the Pacific, and that ball of warm water will then erupt off the coast of Ecuador if it's strong enough and has enough momentum. If you get successive Kelvin waves driven by successive active phases of the MJO, then that can help form El Nino. All right, so right now, winds, we're just looking at the arrows. The colors are sea surface temperatures in centigrade. We see easterly winds, trades pretty hard, blowing the whole way across the East Pacific, Central Pacific, on the date line. A little bit weaker south of, sort of in the Kelvin wave, but no real clear signs of westerly winds. Anomalies. Differences from normal for this time of year. Yeah, we have east winds. They're blowing a little bit stronger than normal over here. Not surprising, because I believe we are in the inactive phase of the MJO right now. And those easterly winds, or those easterly anomalies, weaken across the Central Pacific, pick up again on the date line, and then fade in the Kelvin wave generation area. Okay, so really, what are we seeing here? Well, this data suggests no real clear sign of the active phase of the MJO, but this is a 5-day mean. See that right there? 5-day mean. So winds could be switching in this area, but it would take like 3 or 4 days for this data to pick up on it because it's a 5-day average. But looking at it right now, no clear sign of the active phase of the MJO. And why do we care about the active phase of the MJO? The active phase of the MJO, when it does that westerly wind anomaly thing, it actually takes energy, pumps it into the jet stream, and then the jet stream all of a sudden wakes up, the winds start blowing harder, it consolidates, and then that feeds the storm track. When you're in the inactive phase, which we are right now, you get this less energy transport into the jet. The jet sort of gets weak. It doesn't know what to do. It splits, which is exactly what's going on over the East Pacific. And then the storm machine just breaks down, and so does the rain machine. So that's where we've been the past couple of weeks. No surprise, the snow has stopped in the Sierra. The swell machine has shut down. We have strong northwest winds. All those are classic indicators of, at a minimum, the inactive phase of the MJO. All right, so what is the forecast? The good news is the forecast is looking much better. All right, so what's this chart? This is 850 millibar zonal wind anomalies. That's a mouthful, but basically it's saying, are the winds blowing harder from the east or harder from the west than normal? We don't care about the north-south component, but when they're blowing from the west in the Kelvin wave generation area, okay, so this is the whole planet. Pacific Ocean starts at about 130 east on the equator and goes to about 80 west right off of Ecuador, so between there and there. But the Kelvin wave generation area is what we're really concerned with, because that's what feeds the jet stream. So this area from here to about here, and you go straight up the chart, okay, in that area. So back here, and when you see the reds, the whites or the purples, whatever you want to call that, That is westerly winds, all right? So back in early December, remember we had a bunch of surf and we were getting rain and snow? There was this big westerly wind burst sort of thing going on, the active phase of the MJO. And as soon as that shut down come about the new year, boom, instantly the storm machine shut off, so did the snow machine, right? Well, look at this. Here we are today. This is the beginning of the forecast. And what do we have? We have good news. We have a solid area of westerly wind anomalies forecast in the heart of the Kelvin wave generation area for the next week. And notice here, these are easterly anomalies. This is the residuals from what was the inactive phase of the MJO, now, as of today, filling the East Pacific, right where the jet stream is split. You know, it starts splitting like on the date line. Okay, the date line today is right there. As soon as you just get a little bit of east of there, there's all those east wind anomalies, and that's happening on the equator. And north of there, the jet stream split. So that's why we get so engrossed in what's going on with wind anomalies in the Kelvin wave generation area, because that sets the tone for weeks at a time. The active phase or the inactive phase of the MJO lasts over the Pacific for 3 or 4 weeks at a time. So if you've ever noticed how we get surf and it seems like groups of storms and it'll go for 3 or 4 weeks and pulse, and then all of a sudden there'll be nothing and it'll be flat for 3 or 4 weeks, it's all driven by the MJO. Hence our significant attention that we pay to the MJO. But one model is never enough. We always want to look at a couple of different models, see if there's any agreement between them. So here is a statistical model. Now, this isn't looking at winds. This is looking at outgoing long-wave radiation, another component of the MJO. But it's fancy words for, is it raining or is it not raining? Is it dry or is there more sunlight reflectivity off the ocean surface? Where you have blue, you have negative anomalies. That means cloud cover. That means the active phase of the MJO. So today, per the statistic model, we see a lot of sunlight reflectivity here. The Kelvin wave generation area is like right in here. Okay, so this looks like the inactive phase of the MJO moving east, with the active phase setting up over the maritime continent, getting ready to push into the West Pacific. 5 days out, it's in the West Pacific. 10 days out, it's filling the Kelvin wave generation area, and continuing 15 days out. Certainly looks like the active phase of the MJO building in the West Pacific while the inactive phase just vaporizes. The dynamic model paints a little bit different picture, but still the same thing. Active phase building, but then fading 15 days out instead of being, here we go, as strong as what the statistic model suggests. I like the statistic model output better, but again, 2 weeks from now, who knows? These models change day by day. It's just a rough guideline. All right, phase diagram charts. Statistic model, dynamic model. How do you read this? The circle. Assume you're looking down on the North Pole, and the MJO moves from west to east. Both active and inactive phase move from west to east, from the Indian Ocean over the maritime continent to the West Pacific, under the United States on the equator, right? Across the Atlantic, across North Africa, back to the Indian Ocean. So the MJO travels the whole way around the planet. Wherever the active phase is, let's say it's there, the inactive phase is basically on the other side of the planet. All right, so the heavy dot is where the active phase is right now, the maritime continent. The further that heavy dot is away from this circle, the stronger it is. So a very strong active phase of the MJO over the maritime continent. There's 3 members to this statistic model. 2 of them say the active phase is to push to the east, but crash and get very weak, where one of them says it's supposed to get even stronger as it pushes over the West Pacific. Like that. The dynamic model, the GEFS model, GFS ensemble model, says, let's see, 1, 2, 3, 4, 5, 6, 7 days from now, the active phase of the MJO is to be quite strong in the West Pacific, and is supposed to continue till about 10 days out, and then crash in the West Pacific. All right, so all this looking pretty favorable. Next up, the upper level model. Now, this is used a lot mainly just for the greens should suggest areas favorable for precipitation, but one can definitely interpret that as meaning the active phase of the MJO, and a very strong one at that as of right now. Now, this runs about a week ahead of what really is happening down at the surface. This is upper level, remember. All right, so good support for precipitation in the West Pacific, we'll call it a week from now, and making its way across the Pacific and moving inland over Central America on February 6th. You can add another week to that, so we'll say around Valentine's Day. Inactive phase follows, and it's pretty strong too, making its way across the Pacific through the end of the model run, February 21st, and then behind that, a very weak active pattern. All right, so far, all the models seem to be pretty much in agreement. And then finally, the CFS model. All right, so this is one of those models, again, whole planet on one chart. Kelvin wave generation area between that tick mark and that tick mark going straight up the chart. And, oops, go this way. There you go. So here is today, this dotted contour. That's the inactive phase of the MJO. You can see it. It started right after Christmas. It's making its way off to the east and is supposed to continue for that's a week, so about another week. But here's the active phase of the MJO. We're about a day or two in. It's in the far West Pacific. It's supposed to move into the core of the Kelvin wave generation area, we'll say about 3 days from now, and hold solid until almost February 1st. So the remainder of January is looking like a really big sweet spot for swell production. Now, this is not a guarantee of swell production. It doesn't tell you how big the storms will be that make the swells or anything. But if there was a big X, you wanted to carve out some days on your calendar to surf, this probably 3-week window right in here would be that time to do that. All right, so enough about the MJO. What's going on even longer term? Are we heading towards El Nino or La Nina or what? All right, so the first thing we take a look at is subsurface ocean temperatures. So this is the West Pacific here. This is the East Pacific here. We're not talking about ocean surface. We're talking down in the water. We're looking for Kelvin waves. So these are the anchor lines on the TAO buoys that are strung across the equatorial Pacific, the whole way from East to West Pacific. You take the data and the X's are the sensors on the anchor lines. Take that model, use a model to fill in the gaps, and you can get a profile of the subsurface temperatures. This is 30 degrees centigrade waters. They backtracked some. They've moved back to the date line now. What we want to see is warm water pushing this way. That means a Kelvin wave's in flight. 29-degree isotherm. It was at 170 or maybe even 172 last week. It's easing off to the east. That's good news. Same with the 28-degree isotherm. The 24-degree isotherm, 2 weeks ago, it was back at like 120 or something like. Now it's pushing back into Ecuador. So that sort of suggests that Kelvin waves are in flight. Now we go down and look at anomalies, the differences from normal for this time of year. We have a very good picture here, okay? Positive anomalies. Water temperatures under the equator are warmer than normal. We have a big ball of warm water here, which is it's a Kelvin wave. It's seeping off the maritime continent, been driven by multiple westerly wind bursts, multiple active phases of the MJO. It doesn't have a whole lot of forward motion, but a core of it sitting here, a piece of it broke off, 2-degree anomalies pushing the whole way into Ecuador. The whole subsurface equator region from 150 meters up is warmer than normal. That's very good. That's exactly what we want to see. A little bit of confirmation of that, sea level anomalies. So these are not temperatures. This is the height of the ocean surface. This is JSON 3 data. You strip out the wave heights. You strip out the wind waves. You strip out the tides. Tides create variations in the ocean surface. And what you're left with is a 5-centimeter bump right here and a 0 to 5 centimeter bump filling all this area. Okay, so what that means is warm water at depth. It expands. When it expands, it pushes the ocean surface up just a little bit. And we're only interested right here, like here's the equator, there's South America, there's the date line. You can see there's suggestions that warm water is filling just about the entire equatorial Pacific, and it's even building up some along Peru now and Ecuador here. That's not saying we're in El Nino, but it's saying that we're certainly not in La Nina. Here's a histogram. It's a What has been the trend over time? You can go back a year, February 2019. The reds and the orange, warmer than normal water temperatures. The presumption is there was a westerly wind burst associated with the active phase of the MJO that took warm water over here, pushed it to the east. That in the form of a Kelvin wave. That Kelvin wave erupted along Peru in the May to June time frame. Then two more little Kelvin waves tried to organize, but they stalled. They never made it past about 130 west, something like that. Cool water this past summer built up off of Ecuador, and we were almost worried that we were going into La Nina. But then, sure enough, we got yet another Kelvin wave that built in September due to the active phase of the MJO. It pushed in across the Pacific and right now is erupting off Ecuador. And there is another Kelvin wave. This is Kelvin wave number 6. It is developing. It's not stalling because you can see here it's making its way just very slowly off to the east. And it, too, looks like it's going to backfill after Kelvin Wave 5 here does its thing. So all indications are we're not heading towards La Nina anytime soon. Next up, sea surface temperature anomalies. Not what's going on under the ocean, but at the surface. And we see warm anomalies. So it was actually kind of interesting. Yesterday, these anomalies were backing off significantly along Peru, and all of a sudden they've started building in coverage again, building off of Ecuador. You notice this area is still pretty spotty right now on the equator, and it's not as warm out here as it was weeks or months ago. But still, so the thought is this is Kelvin wave number 5 erupting, still creating warm sea surface temperatures. But also note we have easterly anomalies going on over here. We saw that one in the earlier charts. That causes upwelling and cooling things down a little bit. The trend for the past 7 days, so this is new. We do have warming still, generally off of Chile, Peru, Ecuador. But this little thin line of cooling here just developed today. We don't think that is very significant in that we know that the active phase of the MJO is building. We suspect that all the easterly anomalies that are in play they're driven by the inactive phase of the MJO sitting right in this area, and that's going to be out of here in a week or so, and then we'll be back into sort of this warming regime, and that's exactly what we want. And why do we want warming? Well, warm water causes evaporation. Evaporation lifts up into the atmosphere and that transfers heat energy to the atmosphere. That eventually ends up in the jet stream. That feeds the jet stream, that feeds the storm track, and you know where it all goes from there. So we're always interested in seeing warming, especially in winter months. Wherever the warming is, like south of California, it really needs to almost push into. So if this area is warm in here, that pushes the jet stream into California. That produces rainfall and snow. All right, so we have a very weak warming pattern here off of Peru, Ecuador, Central America. Stronger out towards the Central and West Pacific. The official El Nino monitoring region is from this area, from 5 degrees north and south at 120 west over to 170 west, so a box right there. That's the Nino 3.4 region. This Nino 1.2 region here is very noisy, but we monitor that as well, and let's go take a look at temperatures there. Here's the temperature trend in the Nino 1.2 region today. 0.136, 136 thousandths of a degree above normal, so basically dead neutral. We had one little spike there back in December, but for the most part, we're better than we were back in October where temperatures were below normal, but we're just normal. But it's the official El Nino monitoring region. If you're going to try to declare an El Nino, the Nino 3.4 region is what you want. Today we're at 443 thousandths of a degree above normal, so 0.4 of a degree, trying to get to 0.5 of a degree. You have to be at half a degree or more for 5 consecutive months to declare a El Nino. We're not there, but we're definitely biased warm. You can see even back into October, we've been warm. We had one little negative hit, and then ever since then, we've been warm. So theoretically, it should be feeding that should be feeding the precipitation track and the storm track, but there's more than just water temperatures. There's a whole host of things that go into what the trend's going to be for the winter, especially for California precipitation. But at least, for the most part, everything's looking generally favorable, but it's not strongly favorable. It's just normal, bias slightly warm. So that doesn't, hold a whole lot of weight. So we've talked a bit about the MJO. We've talked a bit about subsurface temperatures, surface temperatures. Now, what's going on in the atmosphere above the ocean? Does the atmosphere sense that there's, warming going on, or is the atmosphere reacts to the water rather than the atmosphere driving the water directly. All right, so what we look at is the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. When pressure is lower in Tahiti, that's in the Pacific Ocean, this daily index goes negative. Well, right now we're at positive 13.57, and we have been for 1, 2, 3, 4, you get about 8 days, something like that. Looks like the inactive phase of the MJO. And even prior to that, we were kind of toggling around. Now, here we are back in December. We were markedly negative and had been for a while. This was the active phase of the MJO, meaning low pressure over the Pacific, West Pacific. We're in the inactive phase. The 30-day average is minus 6.09. You go, oh, that looks good. Well, we were a bit more negative back in January, minus 8.54. But look at that. We're actually more negative now than we were even in December, so that's not bad. Okay, the El Nino indicator is the 90-day average. Needs to be down around minus 15. We're not there. We're at minus 5.49, and we were actually, minus 6.46. It's been toggling around between 5 and 6 and 7 for a month now, and has been for months. So all this says is the atmosphere sort of thinks the same thing in the ocean. Yeah, we're warm. Yeah, we're, sort of biased weakly towards El Nino, but we're not in El Nino. But the good news is we're not in La Nina, and we'll take that to the bank any day of the week. I just realized we missed this one chart when we were looking at the MJO. We didn't look at the 3-month CFS model, so we'll do that real quick. I mean, it's not telling us anything different than what we saw before. Okay, 850 millibar wind anomalies, Kelvin wave generation area between about here and here going straight up. Now, this is past performance here. The oranges and yellows are westerly anomalies. You can see we had a good run of westerly anomalies in November, the whole way through December. This was our little inactive phase, the blue, and there's right there, that's the easterly anomalies going on right now. And starting today, in fact, we'll do the overlay. Here we go. The solid contour, that's the active phase of the MJO. This is the inactive phase of the MJO. So starting today in the West Pacific, the active phase is building. It's supposed to continue into, right about Valentine's Day. Then a weak inactive phase follows, followed by a weak active phase, and things just kind of, and the models have been consistently showing this. After this active phase, a pretty kind of weak, gutless pattern sets up. So this winter, the peak of whatever's going to happen this winter is going to happen in the remainder of January into early February. And after that, things probably get pretty quiet. All right, so finally, what is the long-term trend? What's going to happen not even 2 or 3 months from now, but like 6 to 9 months from now? All right, so let's see. Last year, around this time, we were in a very weak El Nino. Temperatures were 0.7 of a degree above normal. Then we got into the summertime. Temperatures fell negative. They didn't go into La Nina territory, but they were just slightly negative. And then in October, temperatures started to build. Supposedly, the model says today we're supposed to be 0.7 of a degree above normal. We're nowhere near that. This is in the Nino 3.4 region. What were we? 0.4 of a degree above normal, so about half of whatever's showing here. And the model says that's supposed to hold, and we're supposed to stay warm through the spring. Then as we get into the summer, temperatures start crashing a little bit. Now, this actually looks like we're moving towards La Nina, but that's not really the case. There's a consensus model. In fact, maybe we can pull that up here real quick. This is the output from all available El Nino models. There's a bunch of dynamic models you see here, a bunch of statistic models. They mash them all together. You can look at the green line here. The heavy green line is the average of the statistic models. And this goes from, so where are we here? December, January, February, March. You get it. Goes the whole way out to August, September, October. It says we're about dead neutral as we get into next fall. And the dynamic average is the red line, and then the blue line is the assimilation of all of them together. Everything's saying ENSO neutral as we move into next fall. That's not bad. I mean, that's kind of what we figured was going to happen this year. We're actually a little bit warmer than that, so probably next year will be some variation on this year as well, but we're not down here in La Nina, and that's exactly where we want to be. So, the short-term forecast is, a little bit of misery again for about 3 or 4 more days, and the jet stream comes back together, and all of a sudden the active phase of the MJO wakes up. The jet, all of a sudden starts producing storms, and we're back in business, supposedly, and that should last into sometime in early February. So that'd be a good time to go chase surf, go chase snow, do whatever you're going to do. After that, kind of looks like a far weaker MJO pattern, and that would probably mean less support for storm development, less chances for snow. Or if you are going to chase snow, go further north. It wouldn't be as good in California. You'd be better off up in Pacific Northwest or Whistler or somewhere like that. So, and then beyond that, well, no La Nina in the forecast, thank goodness, but no El Nino either, just sort of a neutral pattern. So next year, maybe it will end up being about like this year. All right, well, if you enjoyed this video, thanks. Appreciate you watching. Give us a thumbs up. Hit the like button. If you haven't subscribed, subscribe. You get automatic notifications when we update the videos, but in general, they're always on Sunday evenings. And you can always go to stormsurf.com. You can follow along daily. The models update every 6 hours, so you can get into that if you want to, or you can just wait to the end of the week and we'll go through it with you. And of course, you're welcome to comment. If you have questions, anything, just write a comment down below, and we'll try to answer. We'll do the best we can to answer and get you an answer for your questions. All right, so that's it. We'll do it again next week, same time, same channel. Thanks for watching.